with larger memory. So you can see, I think this is very crucial for using TE in more in more scenarios, just like running the AI model or running the ZK circuit inside TE. Yeah, and what we introduced here is a TE SDK called dstack. So it's a Flashbots X project, which is jointly produced by Phala and Flashbots. So it has 4 major features here. So first is that the support for Docker images. So just input make your own Docker Compose file. We will get this running on the TE directly. And second, it's equipped with the remote attestation APIs and the chain of trust virtualization on web UI. So any users, they can easily verify whether the application is really running inside the TE. The third, it's equipped with the automatic HTTPS, which means every application deployed in the TE will be equipped with a domain, and also with all the TLS certificate that is totally generated and managed in the TE. So the end user, they didn't even, they can just use the current TLS-based solutions to connect to your application. So the final thing is unique from the Phala part is that we will replace the current hardware-based root of trust with the decentralized root of trust that is controlled by the smart contract. So this means your application data is safe even if a single TE node is down, because the data is stored in something else. So you can just initiate a new TE instance to resume the execution. Yeah, so this is one interesting bot, which is running powered by dstack. It's built by the Professor Andrew Miller from the Flashbots team, and he used a dstack to build it. So I would say it's different from the others, like AI agents, in that the whole stack is controlled by the machine. Just imagine, so from the X account, so the email account that control the X account, and also all the AI agents, the AI API key it's used, all of them are running inside the TE. So now we can see, okay, with this is a real AI agent that's controlled by the machine and you can trust. Yeah, and this will unlock a lot of interesting use case. Finally, we just published the world's first benchmark on the TE GPUs. So to show how usable, whether it's usable or not. So the overall conclusion here is that the average overhead is less than 9%, so which is quite good from my side. Yeah. And in the next, my colleagues, Josh, will show you the usage of dstack. Thank you.
Okay, so what I'm going to do is show you just the application that's deployed on our lab server right now, just to give you an idea. So here is a Next.js application. It's, that I've accessed publicly. You can go to this link if you would like as well. What I can do is derive a ECDSA key pair here. So this is an account that is within the TE. From there, I can start signing messages. And we can see TX signature here that you can verify. You can sign type data. So I actually used the VM SDK, just some of the examples they had in there, and just kind of made a mock template here that you can clone and then get started really quick. And then also I sent some funds to this wallet so that I can actually execute a transaction, and this sent 420 GUI to an account that I had just sent to the TE account that was derived. And then also another key feature as well is that you can also remotely do a remote attestation. So on this case, I actually created a remote attestation with some random data, and from there I'll just click here, and it should generate a quote. So I have my quote here. You can then copy this, go into the remote attestation explorer, paste it, verify, and here you can see that this is actually running in a TE environment with the TE simulator, which is what we have you be able to develop on locally. You would get something that would say unverified. But we can also do a little more checks, because you don't want to just trust like our block explorer and just take our word. So you can go on chain as well, and say you want to verify against Automata's verifier here, and you can see that we're verifying on chain, and you can also choose of the different networks that they support as well. So the next part I'll show you as well is another application that's deployed. Is just like a Jupyter notebook, so that you can see like you're able to also support whatever language you would like to build in, and you can then start to get a little more creative. But since you're able to connect to the socket for which is the TAPT socket here, you can then now have access to these two functions, which will be TDX quote, and the parameters that you would pass in is report data.
This Jupyter notebook itself is running inside TE.
So I'll zoom in here, so people can see here. But yeah, so you can run this here and get a quote. So I have a quote here, and then another key feature is derive keys. So you have this derive key function as well, where you would define your path. So you could define your like a root of trust, and then pass in a salt here from the subject. Whenever you generate this, you should this would generate the same key, I believe, on this one here, so that you can derive a key, and then you can then take this key and then either generate like a ECDSA key, or say ED25519, or whichever curve you would like to choose. But yeah, this is kind of like the power that you have with you by building, like Dockerizing your applications, and then being able to then run it in a TE. Some other things that you could get started with, I have created a little cheat sheet here that you can access at bit.ly/dstacks-cheat sheet. But anyways, here it'll tell you how to get started with the local simulator. You'll clone the repo and have the same Next.js application as well. I can zoom in here for anybody as well. And it'll show you how to get started in just a few steps, and then you're right away having an application running and being able to generate local remote attestations and deriving key pairs from there as well. One of the interesting things that we just have like packaged up, but want to see if any developer wants to kind of build upon it, is we created a repo called AI16Z-TEE, and here you have a Docker file, and you can build your own AI agent that can run autonomously and be able to post on Twitter, answer on Discord with like voice or text. You can choose whichever LLM models through the Red Pill API, and also you can have it connect to Telegram, and then also use the derive key to generate wallet accounts for you, so that you can then start transacting on-chain autonomously with these agents. So you can really get creative, and we have a repo here in the cheat sheet for you to check out and get hacking on it however you would like. But I wanted to save some time instead of going deep into the demo to see if there's any questions that some of the audience may have. Oh yes. So if you go to the Phala Network, so the question was, is there any templates or code that they can reference so that they can get started and be able to understand how to build, say, like a model within a TE? So if you go into the Phala Network repo here, we have a few templates under the TE sim template. So this is like the TE simulator. We have like a Python template, Red Pill template, a Next.js application. But if you have like any like kind of like example like where you want to run a model, please come by our booth. We're over here on this back wall so that we can kind of like guide you and tell you how you can get started really quick with this as well. Because we have our full engineering team for you to ask questions for us. Okay, so that'll be it for this talk today. But yeah, thank you for coming and have a great day.